There is a comforting lie we tell ourselves every day, that tomorrow will arrive exactly the way today did, that the sky above us is stable, that the ground below us is permanent, that space is empty, silent, and far away. But none of that is really true. The universe is not calm. It is violent. It is ancient. And it is filled with forces so powerful that if even one of them turned in our direction, human history could become nothing more than a microscopic footnote. Tonight, we are counting down 8 of the most terrifying cosmic disasters that science says could change Earth forever. Some are unlikely, some are inevitable, and a few could happen with almost no warning at all. This is not science fiction. This is physics, gravity, radiation, fire, ice, pressure, and time. And by the end of this video, you may never look at the sky the same way again. Because Earth is not protected. It is simply surviving. Let's begin with the object that has silently shaped our world for billions of years. The moon. Most people think of it as decoration, a glowing rock in the night sky. But if the moon vanished tonight, Earth would begin changing immediately. At first, the oceans would react. Tides would become dramatically weaker because the moon drives most of the tidal pull on our planet. Coastlines, marine ecosystems, migration patterns, and feeding cycles would begin to fall out of balance. But the real danger would come from something most people never think about: stability. The moon helps steady Earth's axial tilt. Without it, our planet could begin wobbling far more wildly over long periods of time. That means extreme climate shifts. Regions that were once temperate could freeze. Frozen regions could become scorching. Seasons could become chaotic. Night itself would change. Moonlight has guided animals, hunters, insects, and entire biological rhythms for ages. Suddenly, many species would be thrown into confusion. And then there's the psychological effect. For all of human civilization, the moon has always been there. Remove it, and the night sky would feel wrong in a way almost impossible to describe. The moon is not just orbiting Earth. It is quietly helping hold our world together. And if it disappeared, Earth would still survive, but it would never feel familiar again. Now imagine the sun doesn't disappear. Instead, it lashes out. A giant solar storm is one of the most realistic threats on this list. The sun constantly releases charged particles, but every so often it erupts with extraordinary force. A powerful coronal mass ejection aimed directly at Earth could slam into our magnetic field and trigger a global technological disaster. Power grids could fail across continents. Satellites could be damaged or destroyed. GPS could go dark. Radio communication could collapse. Air traffic, emergency systems, banking networks, internet infrastructure, and supply chains could begin breaking apart almost at once. This would not look like a Hollywood explosion. It would look like the modern world slowly going blind. No navigation, no reliable communication, no digital finance. Refrigeration begins failing. Water systems strain. Hospitals switch to emergency power. Cities that depend on constant electricity start feeling fragile within hours. And the worst part is that humanity has already had a warning. In 1859, the Carrington event triggered auroras so powerful people could read newspapers at night. Telegraph systems sparked and failed. That was before our world became dependent on electronics. If a storm like that hit today, the damage could reach into the trillions. Recovery could take months or longer in some regions. We often talk about the end of the world as fire from the sky, but for us, it may look more like screens going black, one by one, until civilization realizes just how electrical it really is. Somewhere in space, there are rocks with the power to erase cities. Others could erase nations, and a few could rewrite life on Earth itself. Asteroids are not ancient threats, they are current threats. Right now, scientists track near-Earth objects constantly because even a relatively small impactor could cause catastrophic destruction. Picture a large asteroid entering Earth's atmosphere at tens of thousands of miles per hour. The air in front of it compresses, temperatures rise, the sky brightens, and then, in seconds, a blast of energy greater than many nuclear weapons strikes the surface. Near the impact zone, entire cities vanish. Shockwaves flatten forests. Fires spread. Debris is launched high into the atmosphere. If the object is large enough, the real damage comes after the impact. Dust and soot could block sunlight, cool the planet, damage crops, and destabilize food systems across the world. Oceans struck directly could generate megatsunamis that race across entire coastlines. This is not just theory. 66 million years ago, an asteroid impact helped end the age of dinosaurs. The terrifying part is not only the impact, it is the timeline. For some objects, we may get years of warning. For others, especially ones approaching from the direction of the sun, detection becomes much harder. Humanity could find itself counting down not decades, but days. And when a mountain-sized rock is already on its way, debate ends, politics ends, markets ends. Only physics remains. Not every apocalypse falls from the sky. Some rise from beneath our feet. Deep under Earth's crust are reservoirs of molten rock so vast they make ordinary volcanic eruptions look small. If a supervolcano erupts, the explosion would not just devastate one region, it could alter the entire planet. An eruption of this scale could blast ash miles into the atmosphere, darkening skies far beyond the blast zone. Aircraft would be grounded, cities buried, water contaminated. Breathing itself could become dangerous across huge areas. But again, the longest-lasting damage would come after. Ash and sulfur aerosols in the atmosphere could reflect sunlight and cool the Earth, creating a volcanic winter. Crops fail, growing seasons collapse, food prices spike, famine risk rises, governments strain under panic and migration. This kind of event would remind us that civilization is built on a very thin assumption, that the climate will remain stable enough for agriculture to function. Take that away, and modern life begins to unravel quickly. A supervolcano would not necessarily wipe out humanity, but it could force our species into one of the hardest survival tests in recorded history. And the strangest part is that the danger would begin with something almost invisible at first. Pressure building quietly underground, while people above continue driving to work, making dinner, and planning for next week, as if next week is guaranteed. Now let's go bigger. A planet with no star. A frozen world wandering through the galaxy in darkness for millions of years. A rogue planet. If one entered the outer solar system, it might not hit Earth directly to cause devastation. It wouldn't need to. Gravity alone could become the weapon. The outer planets could experience subtle orbital disturbances first. Then, comets from the distant edges of the solar system might begin getting knocked inward. Over time, the inner solar system could face an increased bombardment of debris. And if the rogue planet passed close enough, it could alter Earth's orbit itself. That change might be small, but in astronomy, small changes become huge consequences. A shift in orbit means a shift in solar energy. That means changes in climate, seasonal patterns, and long-term habitability. Even if the encounter did not destroy Earth, it could transform the sky into a place of constant dread. A giant dark world appearing where no world should be. New calculations every day. New fears every night. This is one of those cosmic threats that feels like fiction because it is so cinematic. But rogue planets are real. The galaxy may contain billions of them. Most will never come near us. But the universe does not owe us distance.
Now imagine a disaster that arrives from across the galaxy at the speed of light. A gamma-ray burst is one of the most powerful explosions known to science. In seconds, it can release more energy than our sun will emit over its entire lifetime. If a sufficiently close burst were aimed directly at Earth, the results could be catastrophic.
You would not see a fireball race toward the planet. There would be no time for evacuation, no meaningful shield. The radiation could strip apart parts of Earth's atmosphere, especially the ozone layer that protects life from harmful ultraviolet radiation. With that shield weakened, the sun itself becomes more dangerous. Surface ecosystems could take severe damage. Ocean food chains, especially plankton near the surface, could be hit hard. Climate chemistry could shift. The immediate blast might not kill everything at once. That is what makes it so haunting. It would trigger a chain reaction. Invisible damage, delayed consequences, global biological stress. A gamma-ray burst is the perfect example of how the universe can destroy without touching. No impact, no invasion, just energy crossing unimaginable distances. And suddenly, a living planet is changed. And somewhere in the cosmos, these explosions are happening right now. Earth has an invisible shield. It wraps around the planet, deflecting much of the charged radiation streaming from the sun and deep space. It is called the magnetosphere, and without it, life on the surface would face a much harsher world. Now, a total permanent collapse is not what scientists expect in normal conditions, but if Earth's magnetic protection weakened dramatically, the effects would be serious. Radiation exposure would increase, especially at high altitudes and near the poles. Satellites would be more vulnerable. Power systems and communications would face greater strain during solar activity. More charged particles could reach the atmosphere, interfering with technology and possibly affecting biological systems over time. Compasses would become unreliable during major changes. Migratory animals that rely on magnetic cues could lose one of their oldest navigational tools. Modern civilization, already fragile under a solar storm scenario, would become even more exposed. The most unsettling part is that you couldn't see this shield with your eyes. Most people would continue their routines, unaware that one of Earth's quiet protections had weakened. Humanity likes visible danger, but the universe often works through invisible systems, fields, particles, radiation, chemistry. And if those systems change, life changes with them. The final disaster on this list is not a maybe, it is a certainty. One day, the sun will die. Not tomorrow, not soon, but eventually the star that made every ocean, every forest, every breath, and every human thought possible will begin running out of fuel. It will swell into a red giant, grow enormously, and transform the inner solar system. Long before Earth is swallowed or scorched beyond recognition, the planet will become unlivable. Oceans will evaporate, the atmosphere will change, surface temperatures will climb to impossible levels. Any remaining traces of life will be pushed to extinction. This is the ultimate reminder that planets are not forever. Stars are not forever. Even the things that feel eternal are only temporary on a cosmic timescale. Everything we have ever loved exists in borrowed light. And yet somehow that is not depressing. It is astonishing. Because against all odds, for this brief moment in the life of a star, Earth became a living world. And on that world, matter learned to ask questions about the universe that created it. That may be the strangest miracle of all. So, what should we take from all of this? Not fear. Perspective. The universe is dangerous. It always has been. But the fact that we are here at all, alive on a small planet with enough time to wonder what could destroy it, is extraordinary. Every sunrise is a temporary victory. Every quiet night is a fragile gift. Every normal day on Earth is far less normal than it seems. Because above us are wandering planets, collapsing stars, invisible radiation, ancient rocks, and cosmic storms powerful enough to erase everything we've built. And still, here we are, looking up, learning more, refusing to stop asking. That is what science really is. Not just knowledge, not just facts, but the courage to face a terrifying universe and study it anyway. If you enjoyed this journey into the most extreme threats Earth could face, subscribe to Infinite Science, because there is still so much more to explore. The universe is bigger than our fears, stranger than our imagination, and we are only just beginning to understand it.